Okay, it's lesson 6.2, number 13. It's on page 322. Definite integral using U substitution. So, first of all, why do we call this a definite integral? What makes it a definite integral? We've got a lower bound and an upper bound. So we have definite starting and stopping place. We're going to, if we were to graph this and find the area between the curve and the x-axis between e and 6, that would be our answer. Now, the reason we want to use U substitution is because we have a fairly complicated expression here. And what I'm going to do is rewrite this a little bit. Let's move the dx out to the side, over here. And instead of dividing by x, what could we multiply by? 1 over x, right? You can, instead of dividing by a number on the bottom of the fraction, you can multiply by its reciprocal. Or you can just think of this as a 1 right here. And you're taking the 1 over x, moving it out to the side. So that leaves you with just a natural log of x on the bottom, right here. If there's nothing left on the top, what should you put here?
1.
A 1, yeah. Again, this could be multiplied by 1, so. And you'll learn to, when you see natural log problems, natural log integrals, that this is kind of the technique you want to use. Get everything off to the side except for the 1 over natural log of x. And we're going from e to 6. Now, let's decide what we're going to let u equal. What do you think we might let u equal? Natural log of x. Yep. And remember what the derivative of natural log of x is?
1 over x.
Right. So it'll be 1 over x times dx. So, once you get good at these, you'll kind of recognize, hey, I want to get my du off to the side. That's the reason you're putting that 1 over x off to the side. So this part of the expression, 1 over x dx, that's equal to du. So we'll just change that into a du. And what would this fraction become here then? Yep, natural log of x is equal to u, so it'd be 1 over u. Now, you have to be careful because now we're changed from x's to u's. These numbers, e and 6, are meant to be plugged in for x. I need to convert those over to u values instead of x's. Okay? So I can do that over here because I have an expression that tells me what u equals. So if x equals 6, u would equal natural log of 6. So natural log of 6 would be my new upper bound right there. If x equals e, u would equal the natural log of e, which is equal to what? 1. That's equal to 1. Good. Now let's do our integral. What's the integral of 1 over u? Just had it on the quiz. Just had it on 2 quizzes. Natural log of u. Now, since it's a definite integral, we're not going to put plus c here. If it was an indefinite integral, if there were no upper and lower bound, we'd put plus c, and we'd be good to go right there. But let's instead put a little square bracket. We're going from natural log of 6 to 1. Then let's plug in. Which number gets plugged in first? Natural log of 6. So you're going to have the natural log of the natural log of 6.
This is like finding area.
Minus, then you plug a 1 in, natural log of 1. You said it's finding area. Yeah, what we're doing is find the area between the curve and the x-axis again. Okay, anyone remember what natural log of 1 equals? Natural log of 1. So what you're thinking is e to what power would give me 1? 0. So this part right here is equal to 0. So you have natural log of the natural log of 6 minus 0. So our answer is just natural log of the natural log of 6. If you wanted a decimal, you'd have to type it in your calculator. Now, that's the way I want you to do today's assignment when you get to definite integrals. But I'm going to show you another method that really on the test, I don't care if you use the first method I showed you or the second method. The second method would be to do this. Not worry about changing your x's, x upper and lower bound, over to u's. Instead, just take this integral of natural log of u right here, going from whatever to whatever, and change it back to x's. But what would I plug back in for u? Natural log of x. So you can change this back to natural log of x I'm changing this u into natural log of x. Then going back to my original bounds, which are 6 and e. Now I could plug in 6, and I'd have natural log of the natural log of 6 minus natural log of the natural log of e. What's the natural log of e equal? Right here, what's that equal? Equal to 1. Because you're thinking e to what power gives me e to the first power. And the natural log of 1 equals what? 0. So you're going to have natural log of the natural log of 6 minus 0. So again, your answer is natural log of the natural log of 6. So either way works. I guess over here, the first method is what I want you to work on today's assignment, lesson 6.2. I'd like you to do it this way. But when you get to the test, I really don't care which method you use. On the review assignment, I don't care which method you use. So this first method is a little shorter, but you have to convert your x upper and lower bounds into u upper and lower bounds. That's the one thing that's different. Any questions about that? All right, go ahead and keep working on that assignment.